Hi everyone. So in this video we will be discussing this pH scale lab. So you will learn how to identify acids and bases using the pH scale, and you will also be introduced to pH calculations. So first you're introduced to the pH in general, the pH scale in general. So you're first going to start by launching the simulation, and then you will see this. And here you're kind of guided into getting to learn how this simulation works, right? So first thing to do, drag the probe, which is the part of the instrument that measures the pH. Drag this green probe into the solution or into the substance, and then you can see that the pH pops up right here, right? See? So you can actually check a bunch of different liquids that we have available here. For example, I just clicked on random one, drain cleaner, and you can see that the pH changes. It went from being 7.0 neutral to being 13 on the basic end of the spectrum. So that's how this pH probe works. That's how you'll be doing these pH measurements, and this is how the scale tells you whether something is acidic or basic. So you're going to continue on. Remember, the first part of this lab, you are just being introduced. So just take it step by step. It's going to be very self-explanatory, and it'll guide you on each question. So first, you are going to work with water. So you can go back to your water. I changed it to drain cleaner, but now it's back on water, and you can see that it's neutral. It's considered neutral. And it even tells you that it's neutral right here as well. And it tells you the volume over here. So notice that you can add in more water. You can add in more through here or through here. And then you can also let water out, meaning you can reduce the volume or you can increase the volume. So there's a few other options here for you as well. So you're going to start by checking if the volume affects the pH of the water. So you're going to experiment, change the volume, check what happens to the pH. Next up, you are going to make some predictions. So a lot of these substances that are given as examples, they are either acidic or basic. They're not really in that neutral area compared to water. And, you know, it's guiding you, it's teaching you what's basic versus acidic. So a solution is acidic when the pH is less than 7 and basic when the pH is greater than 7. So you are going to work with 5 substances that you want to test, and then make sure that you choose at least one that you think is an acid and one that is a base. You are going to write the names of those here. So let's say you pick drain cleaner, you could pick that, and you're going to make a prediction on whether that's acidic or whether that's a base, or you can say acid or base. And it's completely okay if this isn't correct. This is just a prediction. And then you are going to record your results. So for results, you are going to write in the actual pH value, so the number, and then for results in terms of A or B, you're going to write in acid or base, or you can type in A or B, whatever you want. So this should be full. This first column will have the names. This second column will have the prediction, either A or B. This third column will have numbers, the values of the pH. And then this fourth column will have the actual results, either acid or base. And then please write in a few complete sentences how your results compared to your predictions. Were you surprised by any of them? And then once again, you're making another hypothesis, so it's okay to be wrong here, about what you think about other substances, if you think their pH will change, if you add water or remove water. Just make an educated guess. It's completely okay. It's all about just thinking through this and checking and actually doing an experiment to see whether your hypothesis is supported by the data or it isn't. And it's completely okay if it isn't. You're still learning. That's the whole point of the scientific method. And then next up, you're going to test your hypothesis by going ahead and adding or removing water. And then that's the end of the first section. Next up, so I collapsed that first part. And next up, we have comparing hydronium and hydroxide. So this gets a little bit more complex. So first, we were just learning about pH, what values of pH correspond to acidic, what values of pH correspond to basic. And now we're kind of getting into the nitty-gritty of how pH is calculated and what value is used for that calculation. And those values have to do with something called hydronium ion and hydroxide ion. So hydronium ion, all that is what is in solution when you have an acid. And hydroxide is the ion that's in solution. And by in solution, we mean in aqueous solution. That's what's in solution when you have a base. Now, they can both exist when you have just neutral water. And what I meant when I said hydronium is when you have an acid, hydroxide is when you have a base. Hydronium will be in higher amount when you have an acid. Hydroxide will be in a higher amount when you have a base. So they're like opposites of each other. Always think of acidic for hydronium and always think of basic for hydroxide. So here's a different portion of this simulation related to pH, and this one is focusing on micro, meaning that we're zooming in on what's actually going on in these solutions. Versus the previous simulation, we were like, it was very bird's eye view, like very zoomed out. It was just a measurement of pH. Here, we actually can tell how much hydroxide versus how much hydronium. So this one on the left-hand side is your hydronium. This one on the right-hand side is your hydroxide. So let's go ahead and see what this tells us to do. And obviously there's a bunch of different options. So in the last section, we observe pH and how that changes with volume, right? And next up, we are going to explore these concentrations, hydronium, hydroxide. So we're going to start with water. And water, it dissociates, meaning it turns into hydronium and hydroxide. If you add these two up together, you will see that you get two H2Os. And in pure water, remember, water is neutral. And remember, I said, think of acid whenever you have hydronium, think of base whenever you see hydroxide. Water is neutral. It's not acidic. It's not basic. So what that means is that these have to equal to each other. So in pure water, the one that's most abundant is going to be water. Versus in acid, so I gave you the answer for this one. That's okay, but it's helping me explain what I want to make a point of, which is for acids, you have more hydronium. For bases, you have more hydroxide. So just keep that in mind, and that will really, that's a really big main point from this part of the lab. So then it goes to guide you through more questions and just more kind of getting deeper into what you witness when you start studying this. And I want to actually look at an example. So let's look at orange juice. And you can see right away, right, the pH is being measured, and you saw that the pH changed. It went from being 7 for water to now 3.5, which is acidic. And you can see here that there's a lot more hydronium compared to hydroxide. So that's what I meant. When you have something that's acidic, meaning a low pH, you are going to have more hydronium. So you can see that you just saw that happen in real time. And then the rest of these questions like I said, you're exploring this a little bit more, and then you are going to make some measurements. You're going to record some measurements. So you are going to look at soda, coffee, spit, ew, hand soap, and drain cleaner. So you'll measure the pH of 0.5 liters of each substance. You are going to identify each one as an acid or a base. You can just record A for acid, B for base. And then you will read the concentration of hydronium and hydroxide, and you are going to state which one's higher for each substance. So for example, for orange juice, we see that hydronium is higher, and we can also confirm that by seeing that the pH is lower. Remember, a lower pH means very acidic. A lot of hydronium means acidic. So those are the two things that correlate with each other. And that's what you will write here, whether one is more abundant or not. And some more follow-up questions. So that's it for the second section, for part 2. And then finally, the last part, we're again looking at the pH scale a little more in depth. We're actually going to learn the math of how to calculate pH. So here we have the beginning of this simulation. Once again, we're going to work on micro. Okay, so we have that same one. So now we know whether something is acidic or basic, and now we know what corresponds. Hydronium corresponds with acidic, hydroxide corresponds with basic, right? And here, I want you to really pay attention to this section right here, because it breaks down how we calculate pH, right? So we know that the pH of water is 7. That means neutral. And if we look at the concentration of hydronium for water, what you're going to notice is that there's a pattern, and that this pattern comes from this exponent. So basically, this exponent tells you your pH. So you see how it's also 7. This is not a coincidence. It's how the math works. So the way that this math works is you take a negative log of this value, and that gives you your pH. So the way this would actually look when you plug it into the calculator is you would type in negative sign and then log, and then type in that entire value. This is a value. This is a very tiny, small number. It's just written in scientific notation, right? That's why it has the times 10 to the. So you plug in this number, you press enter, and the calculator is going to spit out 7. Here's another example. You have a solution with a hydronium value, a hydronium concentration of this, right? 1 times 10 to the negative 9. You're going to plug this in to the calculator, into the equation. You're going to get 9. So see how that exponent matches up to the pH value? That's exactly what you will notice once you start calculating pHs. So you are going to calculate the pH for this, 1 times 10 to the negative 5th molarity for hydronium concentration. And then from there, we kind of go a little bit deeper into the decimals of the pH value. So, for example, for orange juice, the pH is actually 3.2 times 10 to the negative 4. So how does this 3.2 affect that pH? We saw that this exponent is going to tell us the number, right? But the 3.2 is also going to affect it a little bit. Not a lot, but a little bit. So that's what you are going to see, how that is changed right here when you plug in this to get the pH of this. So just to clarify, you are getting the pH of this right here, 3.2 times 10 to the negative 4. So you are going to get your calculator. You're going to type in the negative value, the negative sign, and then log, and then 3.2 times 10 to the negative 4. And then you're going to try some more. So this is really digging into the nitty-gritty of calculating pH, which is really useful. I think this is a really useful lab in terms of understanding the relationship between acidic versus basic, and pH value versus acidic versus basic. So keep following along and try out the calculations. Now, once you get to this point, what you can do is you don't have to worry about this one. KW, don't worry about that one, okay? There was a portion in this lab that had to do with KW that I took out just for the sake of making it a little bit shorter. So don't worry about KW, just describe what pH is and what hydronium is, okay? And then here you are going to get to practice getting to record for these different solutions. So if you have an H3O of this, you can solve for OH minus. So you can solve for one or the other, but because I shortened this lab, that's not part of this lab. What I'm going to do is make this a little bit simpler. So if you have an H3O value, I want you to determine the pH. So I should see the pH value for row 1, row 6, row 7, row 12. I should also see whether it's acidic, basic, or neutral for row 1, 6, 7, and 12. So I should see the pH and acid, base, or neutral for those rows. Now, for the rest of these, what we can do is focus on what we do have available. So for example, this one, you have a pH of 9. So right off the bat, you can tell me whether it's acidic or basic or neutral. And the same thing for row 5, 9, and 11. So for row 2, 4, 8, and 10, if you can, go ahead and calculate what you can for H3O, for the pH value, and you can tell me whether it's acidic, basic, or neutral. Just try your best. But at minimum, I should see row 1, row 6, 7, 12 completely filled out for pH and acid, base, or neutral. So basically what I'm telling you is try your best. This one may not be completely full. You did learn about KW, the equation for that in lecture, so you could try it out. But I'm telling you right now, as long as I see you try on most of these, then you should be fine. And the point I really want to make here in this lab is you understanding the relationship between pH, whether something is acidic or basic, and how to calculate pH. So with that, I will leave you to your lab. Please let me know if you have any questions at all. I'm available through email. And thank you for watching this video.